let me start with, we are going to present this REC headquarter in Gurgaon. First of all, I am here as a standby speaker. The basic lecture was delivered by my colleague director Abhay GHATE and Nitin Dhariyal. But since both could not make it to Mumbai, so I am presenting on their behalf. So you will excuse me in case I miss out on some important detail. Okay. Okay, let me give very little brief about our company. I represent Optimal Consultant Services. We have offices in Mumbai, Delhi, Vadodara, and also Bangalore. We are having more than 150 professionals working with us in structural design, and we are doing projects all across India and obviously in Middle East also. And we won National Award for Excellence in Consultancy Services, first prize, for the projects in Dubai. We did around 50 lakh square feet 6 buildings in Jumeirah Beach Residency, which you may be knowing, that is the most talked about residential project in the world with area of more than 2.2 crore square feet, out of which we did one segment, which is the largest segment, around 50 lakh square feet. That was way back in 2005, 2006. Now, coming to this specific, why we are presenting it, there are a lot of unique things in this particular project. This is REC, REC bond, probably everybody is aware of it, tax-saving bond. So this is the REC headquarter and considered the Bioclimatic award-winning building. This is architects were Chelsea West. This is the New York-based architect. They won it in a competition. And there are many architectural features which I am not really talking much about it now. There are very unique thing from platinum-rated building, and there is a there are two basements, third basement only for rainwater harvesting. Landscape, very unique landscape with a whole solar panel on top of at the roof level. The biggest unique feature of this is the entire construction is in exposed concrete with white cement with titanium dioxide, TiO2, which gives the self-cleaning, permanent self-cleaning finish, which is the only building in India having such architectural concrete finish. And one more this thing which is not very unique, but it is the integrated with chilled ceiling HVAC system, which poses its own challenges in for a structural design. Then there are large cantilevers, 16-meter cantilevers, and there is a grand pergola at the top, at the level of 33 meters. As I mentioned already, Chelsea West is the architect, and they won it in a competition. And there were 5 blocks, and then each joined together. And there is a one block is auditorium. And very unique feature. I will show you photographs later. And then there are 32 meters spanning, 3-story high bridge structure. And I will just show you photographs, because photographs is the thing which gives you a lot of ideas. So this is the originally concept stage model. You can see the elevation features. This is a plan. Above there is the auditorium. This will give you a little better picture. Yeah. So here this is one which is a west side. You can see the roof. You can see the blocks coming out and how they are cantilever structure and getting connected. This is another view. Now, what is the structural scheme? As I said, basically there are 3 basement ground, 5 upper floors, terrace, and a magnificent large pergola to support solar panel. Obviously, there are large span bridges, auditorium, and cantilevers up to 16 meter. The basic architecture elevation requires the slim circular column, not more than 600 millimeter diameter. And because of size limitation, we had to go for a composite column with high-grade concrete inside. And 600 millimeter for height of 30 meters. So you can imagine the slenderness. The structure was designed as a composite, and the steel were basically SHS section and UC sections. These are the general highlights. I will not, the concrete elements I am not touching much, because in this building, apart from composite and special stitches, concrete elements are very, very unique, and which I'm not really giving you a lot of detailed listing. I'm little focusing in this presentation being, on the structural steel aspects. This is again a view. Yeah. So this is on the right side, you can see that shape, which is a very unique shape. And this is the cantilever trusses coming out. Even the roof, you can see the large cantilevers coming out. This is the same, this thing, which is a model, it has model. There are a couple of views I will be showing. This is what is constructed, and this is what is there in the model. This is the two wings, so to say, 2 parts of the blocks are connecting by this 32-meter spanning bridges, and which is the, you are having the diagonal, but it is basically, this is not a pin connection, this is a rigid connection. Earlier, one presenter also talked about verandal, so this is basically, though there are inclined, it is having a verandal action. And there is a last element is a cantilever, because that building is having an expansion joint. Now you can see here, this is the embedded structural steel in concrete columns and beams. You can see the reinforcement, the column is embedded in the concrete, and also reinforcement, and external is a different finish. It is using a sonata, that is, they used a cardboard ply, cardboard shuttering, and this is specially, but this is one-time use, there is no repetition, because the surface has to be very, very unique, they were looking at. I hope you are able to read the description. So, the rest of the RCC element is not very critical. And I'll show you some connection. This is also, you can see that inclined portion, the finish, originally, actually the project was started by some other consultant, and it was totally RCC. Then we introduced these elements of these trusses. And the MS formwork was not used because of that external finish is that grainy finish you get, and you will not get that finish what we are looking at. That is the reason the Sonata, that one famous French shuttering supplier, he supplied this material. And here the full scale model was made, and then only it was, you can see that model. These are the typical, the column and the base plate detail, how, the 32 dia bolts, the huge bolts which are, you can see the bolts with the stiffeners, and embedded column, which is later on encased. You can see the sleek column, and one very unique this thing is the die-block connections. To our knowledge, this was the first time in India. So when you have you don't want to see the section, you want to see the external surface as a smooth surface. So you can see at the last left side corner, so you get this piece, you get a ready-made piece with both end plates and with the holes. So one side gets welded, other side is bolted. So you have one piece and other piece sits on it. So it is, you get a totally seamless connection. And this was done, I mean, we did not import it. This was partially, a few are imported and few later on the contract. JMC was the contractor and they could develop the this detail at, so you see the column, you don't see externally, there is no splice as such. Okay, there is next one. Yeah, this is the typical detail in how the column starts, and it is not a plunged column. Many times in the composite we used a plunge column, so here it is not a plunge column. There is one more. Now here it is radiant cooling system was used. So so what is so special? Structurally, it doesn't matter, but here, you have this is in Delhi, so we had a temperature gradient of 44 degrees. So for 22 degrees, we had to design the slab. The whole thing, flat slab, you put embedded pipes and then you run the chilled water inside. So the slab had to be designed for that temperature drop, and every floor, every slab had to be designed for that. And it was a PT slab. So in the PT design, we had to incorporate these additional forces so that the net tension is within 3 Newton per millimeter square, which we normally keep for PT. And obviously, it took a toll on the reinforcement consumption. But after construction, no cracks, even when they were, of course, heating was not really required much, but cooling was very much required, Delhi temperature. And this is seamless cardboard single-use formwork system was used. And this is very, and where we had to develop a procedure where they will be joined and where you are taking, from mid-height to mid-height, how you take the column up, and then you do the floor slab construction. And we put down step-by-step procedure, erection of the column and then the construction of the flat slab. And then third is this, the high, 30-meter high steel pergola. This was not designed by, this is designed by the contractor. TT were the contractor's consultant, and we peer reviewed this. There is one video. Can we play the video? So I was keen on showing that because most of our projects we don't make videos. It is a long, little 8 minutes video. I don't know how much time I have. Maybe we'll show it for 4 minutes. So here all the power is generated by its own solar panel. It is a platinum rated project. Of course, this is the video is taken after completion of the project, so it doesn't capture the under construction stages. This is in Gurgaon, near IFCO Chowk. The cambers, etc., were calculated based on the theoretical requirement, and after execution, after the heavy landscaping, etc., everything was normal. The structural steel total requirement was close to 1,000 ton. I think I may stop it because, I mean, the video is little, it's more than 8 minutes long, but by this, I think you got the glimpse of, the 3D picture. Okay, you can. Thank you. Thank you for the patient hearing.